I'm Anil Kumar, and here is exam review for pre-calculus. We call it advanced functions. This is for all the students who have exam tomorrow. I hope this just one video will help you understand all the concepts, bring everything together, get excellent marks. Wish you all the best. We are going to discuss all these topics one by one. We'll consider functions, their characteristics and properties. We'll talk about rate of change, polynomial functions, polynomial equations and inequalities, rational functions, equations and inequalities, trigonometric functions, trigonometric identities, equations, exponential and logarithmic functions, and combination and composition of functions. What you should expect from this particular video is insight to most of these functions. Let me give you a few interesting examples. For example, if I provide you with an inequality represented on a number line, let's say that is the number line, and I want to represent this information where the solution of any function is kind of like this, from -3 to 5. I want you to write this in the form of an absolute function. So we have a double inequality, right? So let's say, and you need to write absolute function whose answer is this. Perfect. So that could be one of the test questions. Second, we could have an example for function with two horizontal asymptotes. Now some of you think that we can have only one horizontal asymptote. Even at this stage, I hope that will help you to understand that a function could have two horizontal asymptotes, right? And talking about functions, a function can be both even and odd. We are talking about symmetry here, not degree, right? So when we say that the function has even and odd symmetry, it does not mean that we're talking about a polynomial with even or odd degree. I hope that is clear, right? So before we get into, I hope this will find you interesting, right? So now talk something about functions and then move on to the other topics. So let us see what characteristics we have understood in this particular curriculum while studying pre-functions. It may be a good idea to start with the domain and range, rather definition of functions, right? So when we say function, we actually think about two things: function with respect to relation, correct? What we know is that every function is a relation, right? So we know every function is a relation. This is known to us, right? But there are only a few relations which are functions. So the relations which are like 1 to 1, or they are many to 1. These are functions. So these relations are functions. So whenever we talk about relations, we are linking two things, correct? What are we linking? We are linking independent variable with dependent variable, right? So it's a relation is link between independent variable and dependent variable. correct? So that is what we are doing all the time. Now when I say one to one or many to one, let me give you a simple sketch or some equations to make it clear, right? Let's take few sketches. We could write equations also, right? So when I say one to one, then function could be like this, for example, right? So every value of x is related with just one value of y. So this is independent variable, that is the dependent variable. Sometimes we write f of x, we call it function notation in that case, right? So that becomes function notation. So simple, right? When we say many to one, we mean it could be a horizontal line. All x values in this case are just linked with one value of y. Perfect. Now something which is not a function, let's talk about that also. Something which is not a function, right? So which is something like this. So this is not a function. Is that clear? The equation of this is not y equals to x square, but something like y square equals to x. Since we have moved some unit, let's say 1, right? Let's say 1 to the right, we could say x minus 1. So if you see y square, that means not a function. Is it okay? So let's be very clear about it. So these are functions which are not functions, and in these cases, what do we see? We see a relation which is one to many, right? One to many. It fails vertical line test. It fails vertical line test, right? So the green color here does not mean pass, right? It fails vertical line test, right? So we should write here that is not a function. Is it okay? Fails. Right, and we call this as vertical line test, right? So we call this, let me push this a bit more. Perfect. So this is what we have learned about some functions. Now we'll take up different ways of representing these functions. Mapping diagram, as you have seen, is a very common way. So let me just sketch mapping diagram here. Now let's link some points. Let's say numbers 1, 2, 3, 4 with letters. Let's say A, B, C. Now what we are doing here is we are linking them. Right? Now the question here is, the question for you is it a function? Take your time and answer. Write domain and range. And range. What do you say? All those who say this is a function, they are wrong. It is not a function, right? It is not a function. Why not? Why not? Do you see the arrows? Do you see these arrows? They are pointing in this direction. And therefore, point C is linked to 3 and 4. So therefore, it becomes one to many, right? So it becomes one to many. It is not a function, right? So because it is one to many. You see C linked 3 and 4. Let's write domain. So domain of this function is capital A, B, C, and the range for this function is letters, numbers 1, 2, 3, 4. Do you see that? So whenever you find elements in domain less than range, it is not a function. Definitely, something is linked with more than one. Right? So as you see here, C is linked with 2 of them. So the trick here is that you have to look carefully at these arrows, else you can make a mistake. Perfect. Now, talking about domain and range, the most interesting question is, let me give you in the form of an equation now, y equals to -1 minus square root of 1 minus x. Okay. So if that is my function, okay, let me make this 4. Okay. Or let me make this 2. Now it becomes a real good question. Now the question for you is find its domain and range. Right? So that is the question for you. So this is your second question. That was question number 1. How are you going to do it? Final exam is round the corner. You could do a couple of mistakes here. I want you to avoid all of them. First step is you should rewrite the function, right? So I'll write this -1 later. This minus I'll keep here, square root. You have to factor -2. Once you factor -2, you get x minus within the bracket 2, not 4. Do you see that? -1. Now I think you can get domain range. Perfect. So the square root function, which normally is kind of like this, is being reflected. This is horizontal or vertical. Outside means it is reflected like this, and this is towards that side. So first step, this is being reflected. Let me show you. First step is being reflected like this. This is for this minus. Correct? And the inside minus means it gets reflected on this side. Now, horizontally compressed by a factor of half. So it becomes kind of, every point comes to this side. Do you see that? Compressed by a factor of half. And then you have to move 2 units right and 1 down. 2 units right and 1 down. So this structure will come 2 units to the right and 1 down. And what you find is something like this. Do you see that? So let me push this a bit more. Is that clear? I hope you can see it now. Now you can write domain and range, right? So domain of this function is x is less than equal to -1. Of course, x belongs to real numbers. And range is y is less than equal to what? I'm sorry. Domain is -2. I'm sorry. This is -2. And the range is y less than equals to -1. Does it make sense? And y also belongs to real numbers. Does it make sense? So I think these are very important points to consider before we really move on with advanced functions. Take your time to grasp and understand, and then look up for my next question. Here is my question number 3 for you. We will now discuss characteristics of functions with the help of a figure. So let me sketch one. Okay, so I make very rough sketches, but I hope they are meaningful. So what I will do here is kind of like this. I'll make a piecewise function. Okay, so we'll have a couple of pieces here. Let's say this is one piece. Okay, now what I'm showing here is a piecewise function which is discontinuous. Do you see that part? These lines indicate vertical asymptote. Okay, now I'm adding a couple of pieces to this. So I'm saying let one piece be kind of like this. Okay, now here I'm trying to show you a horizontal asymptote. Now I will draw another piece. I'll add another piece to this. Let's say it's kind of like this. This part goes up like this and then comes like this. Okay, so that is my function. Let me call few points as this point. Let's call this as -4. This will be +4. Here this maximum is at, I want to make it 4. This is 5 for me, right? That is of course 0. This is 1. Okay, now the idea here is to answer all these questions. So I'd like you to take your time, answer all these questions. The very first question is about domain. So you can see there are two discontinuities. So as far as the domain is concerned, we'll say x belongs to real numbers where x is not equal to ±4. Is that clear? The next question is range. Now as far as the range is concerned, since this part crossed the line, we can say that the range is y belongs to real numbers, and that's it. I have not drawn an arrow, but it kind of means, right? So range is all real numbers. Now important thing here is to understand increasing and decreasing intervals. Now this is called increasing. So the increasing interval we could write here from -infinity to -4. It is increasing. And then it increases from, let's say this is the peak, okay? So 0 to 4. So we say union 0 to 4. And then again it increases from 4 to 5. So it increases from 4 to 5. Decreasing intervals. It only decreases between these two, which is from -4 to 0 union after 5 to infinity. Positive. It is positive everywhere except for this interval. So let me write down these values. Let these values be -3 and +3. So we can say it is positive from which to which. So we could write in many different ways. One could be this curly brackets are must, right? So one could be it is positive from -infinity to -4, and then it is positive from -4 to 3 minus, right? Then it's positive from 3 to 4, and is also positive after, let's call this point as 4.2. 4.2 to infinity. Does it make sense? It is negative only in these intervals from -3 to +3 and from 4 to 4.2, let's say. Is that okay? Real zeros. So we have two real zeros, rather 3 here. So zeros are at x equals to ±3 and at 4.2. Asymptotes. We have 3 asymptotes here. So we have vertical asymptote at x equals to ±4 and a horizontal asymptote at x y equals to +1. Do you see that? End behavior. End behavior means when x approaches -infinity, y approaches what? It approaches 1. And when x approaches +infinity, y approaches also 1. That gives you the definition of horizontal asymptote. Perfect. Even odd symmetry. Now, this is not symmetric, so it's neither. Does it make sense to you? Right? So these are very important characteristics which you can read from a graph. In the last question here, question number 4 for you is, let me write question number 4, and that is on even and odd symmetry, right? So check Find symmetry. For these functions, let's say f of x equals to sine x cos x. Now this function it has even symmetry or odd symmetry. That is your test question. Is that okay? Now figure it. I'll give you the answer that this has odd symmetry. Why? Well, some of you can just sketch it and also think about it as half of 2 times sine x cos x, which is half of sine 2x, and you know this has odd symmetry. Perfect. You could sketch it. Shall I? Okay, let me just sketch it here. So basically it's a function which is kind of like this, where the time period has been reduced to pi, 0 to pi. Do you see that? Sine 2x. So there are 2 ways to pi. Well, you could also find f of minus x and prove it, right? So the question here is still, the answer is there for you. My question is prove algebraically, right? Prove about the symmetry of the given function. So I hope that makes sense. And now, since we have good knowledge about the characteristics from graph, let's take up 2 more examples based on characteristics of functions. Now we will try to understand absolute function. I have observed that absolute function is least understood by most of the students. Well, we define this function as a piecewise function. It is as equal to x when x is greater than or equal to 0 and negative of x when x is less than 0. That is what absolute function is. A good way to represent this function is just to draw a line which is y equals to x. So if I draw a line here, this line for me is y equals to x. To make it absolute x, what do I do? Well, this part here is same as the line itself. However, the part which was negative has been reflected, minus x. Do you see that? So this part here gets reflected, and what we get here is absolute x. Does it make sense? Right? You know, square root of x is always positive, right? Square root of x is always positive. Now, very important function is square root of x squared. That is also positive. So what is square root of x squared? Some students think it is x. No. X could be positive or negative. You can see here. X could be positive or negative. So that is not x, but it is absolute value of x. So this gives me another very, very important definition of absolute x. So in advanced functions and in calculus, we are going to use this particular definition of absolute value of x a lot. Now there is one more place where students are getting confused about writing double inequalities, solving them, and representing them as absolute functions. Let me give you an example. We'll take some inequalities here. The simple ones, which you all know, are kind of like this. If I say like this, write it as absolute function. So in this exercise, we are going to show results on number line and write them as absolute function. Perfect. For example, if I write these numbers as minus 3 and plus 3, something in between could be written as absolute value of x should be less than what? 3, right? Since the center value here is 0, So anything in between plus and minus 3 could be represented as shown here. Now I'll give you a few more examples. You need to write them as absolute functions, right? So these are a few more number lines, and that is the most important test question for you. So let us say that I change this a bit, right? So I make it more towards the left here. Okay. So I change it a bit by writing instead of minus 3 minus 5 and still keep this as 3. What happens? Can you write this as an absolute function? That's the first question. The second one is, I have only one point here, right? And that is not included. All else is included. How to put this as an absolute function? Now these are very difficult questions to answer. Now in the case which we are considering here, we'll go through the definition. The idea is to find the midpoint. So in this case, find the midpoint. So what is the midpoint here? Add them, divide by 2. Minus 5 plus 3 divided by 2, which is minus 2 divided by 2 or minus 1. So this midpoint is minus 1. How far are you from midpoint? You are 4 units away, right? So you are, how far are you? That is, how much is this distance and how much is this distance? Each distance for you is 4 units. And therefore, you want to be within that. You could write a function as move to this, that is x plus 1, but be within 4 units. That's how you get it. Now see, if I fill this up, in that case I want to include it. So I'll write less than equal to. Do you get my point? Now in this particular case, how will you write the solution not equal to 3 in the form of absolute function? Well, this means what we are saying here is that x belongs to real numbers, so that x is not equal to 3. How do you represent this as an absolute function? This is the question for you. Can you tell me, please? Well, we could say that absolute value of x, don't want it to be 3, right? So let's bring it to 3 first. And now what? We said this is greater than 0. As you know, at 3 it will be equal to 0, and therefore the solution of x minus 3 absolute value greater than 0 will be represented by this. Does it make sense to you? Does it make sense to you? Correct? Now here is the question which you should be doing, and what I'm doing here is taking it outside, so less than becomes greater than, and I'm changing these values to, let's say this is minus 1 and this value here is 7. Now write this as absolute function, right? So that's the question for you to do. So I hope that gives you a fairly good review of relating absolute functions with number line, their basic definition, and that will also help you to solve many questions relating to equations, inequalities involving absolute functions. I hope that helps. So let's move on and take up square root function now. Well, there is last minute request for square root function. Let me add this to the current series on exam review. So we'll now talk about f of x equals to square root of x. So quickly, let's go through the graph. It looks like something like this, right? And the characteristics, as you can see from the graph, is that its domain and range both are restricted. We can actually graph this function using 5 critical points, which we say key values. X equals to 0 will give you y0, x1 will give you y1. For 4, square root is 2, and for 9, square root is 3. We should take, as it approaches infinity, y also approaches positive infinity. That gives you the characteristics. Now there are some important questions on this, and one of them is to find domain and range of square root function, right? That is very important question. So let's take one example, which is, let's say g of x equals to square root of let's say 4 minus x, right? So it is a relatively simple question, but you may make some errors in doing this. So let's rewrite this function first. So we get g of x equals to square root of minus. It's very important to factor out the coefficient of x. Now once you do that, it is simpler. You know, it is reflected on y-axis and move 4 units to the right. So you could get a function which is kind of like this, where that point is 4 for us, and now you can easily write domain and range. Is that clear, right? So not a difficulty, correct? So what do you find here? That for question 1, we could write answer 1 as that the domain for this function is x is less than equal to 4, and range y is greater than equal to 4. Perfect. So that is how you could get your answer. Now here is a question for you to do. So we kind of did it. Now you do question number 2 as a practice question. We'll write down domain and range of, let us say, f of x, which is 5 minus square root of 3 minus 6x. So that is a test question for you. Now let's look into other types of questions which you could have relating to square root functions. Well, you know this expression x squared plus y squared, rather the equation equals to 25. It really represents a circle. Perfect. It is a circle where the radius is 5 units. So you can say it's a circle where this radius is 5 units. So this is 5, this is 5, all that. However, if I put a condition here, then this may become a function, right? So this is not a function since it fails the vertical line test, correct? It fails the vertical line test because these 2 points being crossed. So it is not a function. See what happens if I say x squared plus y squared equals to 25, where y is greater than equal to 0. Now if I put that as a condition, then what? Then we are talking about semicircle. Then we are talking about semicircle, which is a function. Now this is very important to understand. Perfect. Now let's re-look into this particular equation. So when I say x squared plus y squared equals to 25, we can rearrange and write this as y equals to what? Taking x squared to the right, we get 25 minus x squared, y squared, y. So we square root. Do you see that? So whenever you square root, you have to write plus and minus. So y is plus and minus 2 values, and therefore it is not a function. But if you take only one of them, y greater than equal to 0, it becomes a function. Do you get an idea, right? So that is very important to understand. Now the question for you here is, which is normally a test question, is to find inverse of y equals to, let's say 1 minus square root of x minus 2. So you have to find inverse of this function and write down your answer. Well, let's look into this. We can swap x and y and solve. So let's do that. So we say x is equals to 1 minus square root of y minus 2. We bring it on this side and say square root of y minus 2 is equal to 1 minus x, and then we square. So y minus 2 equals to 1 minus x whole square, and then we say y is equals to 2. We'll add 2, right? So 2 plus 1 minus x whole square. We'll write this. Now, is that the inverse of this function? Is that the inverse of this function? This is the question, right? So the answer is no. The answer is no. It is still incomplete. Can you tell me why? Can you tell me why? Very important. So when you're looking into this particular function, we know here the domain is what? Domain is that x should be greater than equal to 2, and range is that y should be, this is, I'm sorry, the domain is, sorry, so the domain is greater than equal to 2, because if I put x value here as 2, you get 0. And if I put x greater than 2, that's fine. What is the range? Let's try to sketch this function and find the range also, and then we'll get into this part. Okay. So as you can see, here we have reflected from 1, right? So since we reflected from 1, we are at 2 here, and reflected from 1, the graph is kind of like this. That is this function. Is it okay? So the range here is less than equal to 1. Now when you write inverse of a function, domain and range swap. Do you get the idea? So what I'm trying to say here is swap domain and range. That is very important. So that means in the inverse function, you have to say that y equals to 2 plus 1 minus x whole square, where x is what? X is this value. X is less than equal to 1. Then it becomes the inverse of the function. Now you can write down the answer that inverse of this function is a function and is equal to 1 minus x whole square plus 2, where x is less than equal to 1. Do you get it? It is most important thing to understand. So I think these are very important things which you should understand about square root functions as we move along. Hope that helps. Feel free to ask your questions, share and subscribe my videos. Thanks for watching and all the best.